Hey, welcome back. This is the Unit 7 review. We're looking at logs and exponents. So I just pulled up the review here. What I'm going to do is go through different problems, kind of remind you how to do these. I think that'll set you up for success on the test. Shouldn't be difficult. Here we go. Start with the first set we need to evaluate. Remember the way that I say these, we'll do number 2 because that looks pretty easy here. The way that I say these is the exponent I use on 2 to get 16. So it's 2 to some power equals 16. Alright, well, that's going to equal 4. Okay, 2 to the 4th power is 16. We'll do number 3 as well. So 4 to some power up here equals 1/64. Alright, so that's going to be a negative 3. Alright, so you basically just have to say to yourself differently, yeah, there is a way in your calculator that you can just go and plug this in and it'll figure it out for you. So that should be pretty easy. Here we go. Exponential form. So the exponent I use on 3 to get 9 is 2. So they just want you to write it like this. The exponent I use on 3 to get 9 is 2. Alright, so how about 6 here? This would be 5 squared equals x, and we're done. I mean, that's all you can do with those. Now, condensing and expanding. You have to use those logarithm rules, just like your exponent rules here, to try to condense everything means put it all together. Obviously, and expand means take it all apart. So we'll do number 8 here. What I'm going to do is I'm going to bring that 2 up on top of the x. So this is log base 6 of x squared. And then it's minus log base 6 of 7 to the 5th, because remember that coefficient can come up as an exponent. Now that we have subtraction going on, we know that we can divide these two parts right here. So we're going to end up with log base 6 of x squared all over 7 to the 5th. And that is condensed. Expanding. Let's look at 10 here. Whew. What do we got? Log base 5 of all this stuff, square root. Remember, square root is the 1/2 power. So this is equal to log base 5 of x, y, z all to the 1/2. But I'm going to have to use parentheses there. I'm going to bring that 1/2 down in front. All right, or I tell you what I'm going to do. I'm going to distribute that to each one of these right now. So we're going to get log base 5 of x to the half, y to the half, z to the half. And now, because we're multiplying all of these, okay, how can I rewrite that? Well, there's multiplication. We can write it as the addition of two logs. All right, so this is all going to equal log base 5 of x to the half plus log base 5 of y to the half plus log base 5 of z to the half. Okay, now all of these 1/2s can come down front. Final answer, 1/2 log base 5 of x plus half log base 5 of y plus half log base 5 of z. Woo, that was fun for everybody. All right, next one, solve. Now, normally when we solve these, one way to do it is to get a common base. It's probably the easiest way. So I know that this one here I can write as 6 to the 0 power. I'm going to do number 11. So, what can we do here? The rules of exponents say we multiply those two exponents. So we're going to get 6 to the 2x squared plus 10x. Don't forget to distribute, equals 6 to the 0. But that gives us, look, common base. That means the exponents must be the same. So we're going to get 2x squared plus 10x equals 0. This exponent has to equal that exponent. Set it equal, you can factor it and solve it. All right, let me keep going here. Number 14. What are we doing here? I don't know what we're doing. Let's divide each side by 10. Divide each side by 10. So the log base 7 of x equals 21/10. So the exponent I use on 7 to get x is 21/10. So if we raise 7 to that power, this is the exponent I use on 7 to get x. So if I use that as an exponent on 7, it should give me x when I'm done. So you raise 7 to this power, so x is going to equal, in this case, 7 to the 21st tenths. How do you say? I don't even know how to say that. That's crazy. Figure that out and round to 3 digits where applicable. So right here, that would be one case where you round it to 3 digits. All right, let's look at number 13. 5x plus 2 equals 20. Subtract, we're going to get 5x equals 18. So now what? I would take the log of both sides. Okay, so the log of 5x equals the log, let's rewrite that, equals the log of 18. So x times the log of 5, because that x can come down front, is going to equal the log of 18. So what's x going to equal? The log of 18 over the log of 5. All right. Other than that, they're all pretty similar. Let's come down here to number 18. Divide both sides by 10. What do we get here? Divide by 10. So we're going to get the log, a lot of base 7 today, of x minus 3 is going to equal 6.6. All right, so the exponent I use on 7 to get x minus 3 is 6.6. If you raise both as a power on 7, you're going to get x minus 3 equals 7 to the 6.6. I think from there you can figure it out. Okay, don't forget number 17 here, ln, that's just base e, so you have to raise things to the e power. Okay, I'll let you look on the review answer key for that one. Okay, use change of base to evaluate the following. So the change of base, well, what does that mean? That means we're going to have a new log with a different base. So in this case, this is going to equal the log of 160 over the log of 42. Figure that out in your calculator. Nearest 3 decimal places. Inverse, if you remember how to do that, we got to switch. Remember, this is like y equals 8 to the x minus 2. But let's switch x and y. So we're going to get x equals 8 to the y minus 2. So now what? I would take the log of both sides. So the log of x, now let's write it down here. Log of x is going to equal the log of 8 to the y minus 2. But that exponent can come down front, right? So we're going to get the log of x is going to equal y minus 2 times the log of 8. So now what? Divide both sides by the log of 8 and then add 2. That should help you solve that one there. Okay, regarding these applications, remember 7.3, the whole answer sheet has every single application worked out for it. So that should help you figure out those. I mean, basically, it's just plug it in and figure it out. And lastly, these, what do you call these, review skills. Remember, we have 2 important triangles. Our 30, 60, oh, that's terrible. That is terrible. That is equally terrible. Where's my right angles today? All right, so 30, 60, 90. And remember the sides on 30, 60, 90, 1, 2, and a radical 3. And then our other one's the 45, 45, 90, where those are congruent. And that's 1, 1, radical 2. So to solve these, you just set up little proportions here. So I'm going to look at number 2. So across from the 60, let's see, this angle here would be a 30. So across from 30 is 3 radical 3. So we're looking in this triangle, across from 30 is a 1. So 1 is to 3 radical 3 as, and we'll solve it for a first, that's the hypotenuse. So we started over here, 1 is to 3 radical 3 as 2 is to a. Those are both the hypotenuse. And now it's just a cross multiply thing. So when we cross multiply, we're going to get a is equal to 6 radical 3. For b, well, I know that b is the side across from 60. Okay, and that is just whatever the side across from 30 is times radical 3. Alright, so I can take this side here, 3 radical 3, multiply it by radical 3, and I get, what do we get there? 3 radical 3 times radical 3. Radical 3 times radical 3 is radical 9, which is 3. 3 times 3 is 9. That's awesome. Let me do it the other way. Okay, so the other way would be, start over here, 1 is to 3 radical 3. As, and now we're solving for this one, radical 3 is to, over here is b. And you cross multiply, you get the same equation. You're going to get 9. That's basically it. Good luck for you on this test. This is Mr. Kelly in K-Town. Remember, it's nice to be important, more important to be nice. See